All right, let's talk about chemical antimicrobial agents now, and different chemicals that we can use to control microorganisms. So these are the tables that come from your book. Okay, so these are kind of important to go through and to look at. So we'll start off with, let me get my highlighter here. Oh, that's eraser. Let's try the highlighter. All right, so we've got what are called halogens, are the chemical agent. So out of the halogens, we have chlorine. Chlorine's considered a halogen as a chemical group. And we have iodine, which is also a halogen. So both of them affect proteins and nucleic acids. Okay, so they're going to basically kind of denature proteins and, as it says here, kind of denature enzymes. Okay. So chlorine can work on a variety of surfaces, and it can be added to water to make it safe to drink, right? So we find a lot of times that chlorine is used in water facilities or water treatment plants, right? So treating drinking water. All right, so it kills bacteria and it can kill endospores, which is important, right? Same thing with iodine. Can kill endospores, but it does so slowly, okay? So chlorine is typically cheap. It doesn't leave a residue. Chlorine acts quickly, but it can be corrosive and it can be an irritant, okay? So usually it's not something that we would use as an antiseptic, although it says used to treat wounds and skin surfaces, right? But usually you're not putting kind of chlorine bleach on your wounds to treat them. There's other things that we could use. Iodine, for instance, is what we would use on your skin. So iodine is used as an antiseptic to decontaminate the skin. So povidone iodine is used a lot of times. So you'll see there's certain concentrations of iodine, 2% iodine or 2.4% if you're using sodium iodine, or a potassium iodine, right? So this is good. So it says here, used to prepare skin for surgery or to treat burns and as a disinfectant. Okay. So, all right, so I think we're good there. Apologize that my highlighting is so miserable. All right. So we said halogens are capable of denaturing enzymes or proteins. So halogens, if you look at them on the periodic table, they kind of want to pull electrons away from other things, and so that causes oxidation when you pull off electrons, and that tends to destabilize them, right, when you start pulling off electrons. Okay. Chlorine can also be used as a gas. All right, so and when it's mixed in with water, it forms hypochlorous acid in water. So that way it can move in and out of cells the same way that water does. Sodium hypochlorite is actually bleach. Chloramine is what is added to drinking water, and it's longer lasting than regular just chlorine, but it can be deadly to fish. So this is why you buy chemical treatment that removes the chloramines from water in your aquarium, if you're going to try and keep fish as pets in your house, because most of our water is chlorinated and you want to get rid of the chloramines in the water so it doesn't affect your fish, right? Because it can be irritating to the fish. All right, let's talk about oxidizing agents. So we have the oxidizing agents of, let's see here, oxidizing agents. Okay, so typically hydrogen peroxide is what we're considering with oxidizing agents. Okay, so it's H2O2. So it has extra oxygen, which oxidizes things, which helps to kill germs. So oxidizing agents are most widely used as disinfectants and antiseptics. They typically have to be stored in dark bottles because light can deactivate them. So that's why when you get your hydrogen peroxide at the pharmacy, it's in a brown bottle, right? Because you don't want light to get at it. So hydrogen peroxide helps to destabilize molecules. So this is really good for treating anaerobic microorganisms because they don't have a means of handling oxygen forms. And the percentage of hydrogen peroxide is important for how effective it is at killing microorganisms. So typically there's what's called food grade hydrogen peroxide, which is about 35% hydrogen peroxide, which is actually toxic to you if you were to put it on your skin. You may have, when you were little, your mom may have used hydrogen peroxide on a wound. And it does say it here that it's used for wound cleansing, but this is actually not something that is advised any longer. So they actually advise not to use hydrogen peroxide as an antiseptic, and they say that it actually does more damage than good. And that's because it can irritate skin cells and actually kill skin cells in addition to killing the microorganisms, right? So can be used as an antiseptic, but it's no longer really recommended as an antiseptic, right? And if you look, we got the 35%, all right, hydrogen peroxide used in low temperature sterilizing cabinets for delicate instruments, right? So if you increase your percentages, right, you can achieve sterilization, okay? Aldehydes are next up here. So aldehydes pull hydrogen atoms off molecules and they replace them with different chemical groups. So this tends to affect DNA and RNA. So they are used as disinfectants but not antiseptics because they are carcinogens. Okay, so not something you really want to use too much. All right. Let's see. I'm just trying to see what it said there. So glutaraldehyde is a sterilizing agent. So when you hear glutaraldehyde, you have that aldehyde. So think of formaldehyde, right? So formaldehyde is like a preservative, and it's stinky. It smells bad. And that's what glutaraldehyde is, kind of a relative of that. So it stinks and it smells bad as well. So not the best things that you really want sometimes to be using. So you wouldn't use that as an antiseptic either. But it would be used to sterilize respiratory equipment, endoscopes, dialysis instruments that might get a soak in the glutaraldehyde. All right. So as it says, kind of dental instruments, dialysis material, okay, would be your aldehydes, but you wouldn't use them as an antiseptic. Then we have our gases, sterilants, and disinfectants. So this is dealing with ethylene oxide. So it's a gas, not a liquid, but it can sterilize things. So typically it disrupts DNA replication. Ethylene oxide is a bad chemical. It's kind of like your last resort for plastic instruments that can't be exposed to heat or other chemicals. It can be used to sterilize packaging materials, but typically you have to have a large chamber in order to do that. And as it says, ethylene oxide is explosive, right? And it's a carcinogen. So not something you really want to be around too much, okay? So here it says, oops, I'm on the erase button. All right, ethylene oxide is rated as a carcinogen by the government, and it's explosive. All right, so it's going to be very specialized use, in other words. Only certain companies will be using kind of that ethylene oxide. Then we have phenols. All right. So phenols denature proteins and they disrupt membranes. All right. So there we are. Disrupt membranes, disrupt cell walls, affect proteins. Okay. So phenol was actually used by Joseph Lister back in the 1860s to disinfect surgical wounds. And from that we get Listerine. So Listerine was used as a mouthwash and originally had phenols in it. Now Listerine uses menthol and plant oils instead of phenols. So phenols are replaced with what's called phenolics, which are more effective, less toxic, and much more stable, and tend to persist on surfaces much longer, which means they're not good in households, some of your phenolics, because you don't want them to hang out on your surface for a very long period of time. So these were originally used in things like Lysol. And then at some point they changed their formulations over time. All right. So they're not used as antiseptics. And it says many phenols were banned in consumer products, including triclosan back in 2017. Okay. So it says phenol is used only in certain limited cases, such as in drains, cesspools, and animal quarters. All right. But then we have phenolic disinfectants are rated, right, depending upon how well they achieve their control as compared to phenols. All right, next up we have chlorhexidine. Chlorhexidine is good at disrupting cell membranes and denaturing proteins. Chlorhexidine is used as a surgical hand scrub, so surgery prep soap basically prior to surgery. Patients might be sent home with chlorhexidine, or they might be given an oral rinse for tooth surgeries. So chlorhexidine is usually fast, effective, and it's mild. So this is an antiseptic, great for using on your skin. Alcohol denatures proteins and disrupts membranes, so it can be used as a disinfectant or an antiseptic. It's cheap, but it disappears immediately by evaporation, so it goes away very quickly. 70% ethanol or isopropyl is the effective strength. You need to know that 70% is. And you need water, so you can't use 100% alcohol because it's not effective. You need water to help disrupt membranes, and you need time as well for it to be effective.